help my farm. Grow some crops for me. So at this point, I emailed Anna. We're bonding. As Robert. And I got her to hit a link. Ooh, a link. Right? This goes back to the web browser. So I'm going to attack her network now. So you guys are familiar with this is your network, right? This is your network on drugs. A little U2. So we're going to talk about a NAT right now and how to break a NAT. So this is a NAT. This is your home NAT. Your NAT basically allows you to run multiple systems behind one public IP address, in a nutshell. We won't go into it much further than that. So you all have private IP addresses back here. Let's say this is your system, or this is Anna's system, as you can tell. And she's running behind this NAT. It doesn't matter if you have, let's say, ports running on your system. If you have services running, for example, you're running Apache or whatever, it doesn't matter. Your NAT will actually block it out unless you're doing port forwarding or using a DMZ. But, yeah, that's it for this slide. So what we're going to talk about first is something called XPS, cross-protocol scripting. You may have heard of it recently. It was made kind of big by a well-respected group called Goatsy Security. So cross-protocol scripting. Basically, with an HTTP server, you can run it on any port. A little more information here. With a hidden form, we can basically submit data to any port to any HTTP server. What's interesting about this is HTTP is a new line-based protocol. What that means is when you're doing HTTP requests, every piece of data is on a new line. Now, there are other protocols that work like this. SMTP, for example. When you connect to an SMTP server, you say, hello, and a bunch of other stuff, and you say, I want to send mail, recipient, body, or data, so on and so forth. IRC also works this way. So the cool thing is, you can actually talk to an IRC server, make your browser think that it's an HTTP server, and your browser will first send the HTTP request, and in the content or in the post data, send IRC commands. What will happen is the IRC server will actually look at that HTTP response and be like, I don't know what this is. Ignore, 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 until it gets to valid commands that it understands, and then execute those. So in this example, we're just telnetting to an IRC server. We basically, to demonstrate how new line-based protocols look, we send something like user Samy, Nick, Samy. Might have to respond to a ping request. We join a channel, and then we ask them where to get WinNuke. It doesn't work anymore. I tried it. Oh, is it? Yeah. So at this point, this is how you would actually produce that in HTTP. We can actually, most of this can technically be in HTML, but here's a JavaScript version. We basically create a form. We say where that form is going to get posted to. We're going to post to an HTTP server called fnet.org, or irc.fnet.org on port 6667. And then we're going to use multi-part form data so we can send basically post content that doesn't get URI encoded. It'll be the data that we want to send to the server. We send the data that we want, and then we go ahead and submit the form. What we see is this. Our client, our browser, creates this connection to an IRC server. The IRC server doesn't understand any of this stuff. Ignores, ignores, ignores. Oh, I understand these commands. And then it goes and executes that. One of the dangers of this is you could write, for years and years and years, there have been spammers using this. I don't know how many people know about this or how many spammers even know about this, but basically what was happening was you would have a website that got a lot of traffic. And someone would visit that website. And on that website was code, this type of code. And it would connect, each time you hit that website, it would connect to a random mail server and then send an SMTP message through that mail server. Now, it's much harder to block that spam because it's coming from random IP addresses. It's all of you who are visiting the website that your browser is now acting as a mail client. It's really dangerous because now you have all these random IP addresses that you can't necessarily control. So what is NAT pinning? That's what I'll be talking about. It's like XPS times over 9,000. It's really cool. So where XPS confuses the browser, it makes your browser think you're communicating with an HTTP server. NAT pinning also confuses your router. So when you're communicating with port 6667, your browser thinks it's HTTP, but your router thinks it's IRC, which is sort of true, right? It's a mix at that point. So what happens is Anna Ferris clicks on that link. She goes to some malicious server that was supposed to be HP. I don't know what happened. And she hits a web page. That web page has a hidden form, and then it does a JavaScript submit of that form, which then connects to, say, an IRC server. All right, well, we just talked about that. That's cross-protocol scripting. You know, those respectable goats you guys told us all about that. So what else can we do? Well, IRC is a cool protocol. If you're familiar with IRC, you may be familiar with DCC chats or DCC file sends. DCC is basically a direct client connection. It allows you to make a direct connection from you to the person you are chatting with or you want to send a file with, rather than going through the middleman of the IRC server. You might not want the IRC server to know what you're talking about with that person in Russia. So you'll use a DCC connection. Now, for a while, DCC connections wouldn't really work as NATs were becoming more and more prevalent. IRC is an extremely old protocol. So what router manufacturers started doing was they started creating connection tracking. So if they saw an IRC connection, they would say, oh, this looks like IRC. This guy's probably going to have some wholesome fun in Teen Chat. And what I will do is I will monitor this connection. And if I ever see my person behind my NAT trying to connect to, let's say, a direct person somewhere else, what I'll do is I will open that port. The way DCC works is you say, I want to chat this person, and I want them to connect back to me on this port. That's where I'm waiting for their direct connection. But if you're behind a router, your router is going to block that connection when that user comes back to connect, right? NATs, by default, will block incoming connections. So when routers now see this, and you can actually see some source code, for example, in Linux, if you take a look at this code right here, this will show you the connection tracking for IRC. There's connection tracking for other protocols as well, FTP, SIP, so on and so forth. Now, when the router sees this message, private message, I want to DCC chat this person and I want them to connect back on this port, well, it will open that port. So the router opens that port and sends it back to the client. What if I said, private message, I connect to an IRC server and I say, I want someone to connect to me on port 22 SSH to see this file. Your router will open up port 22 and forward it to me or back to the client. The cool thing about this is it's not a client, it was your web browser. You just visited my malicious website. I had a form on my website that said, oh, I'm going to connect to this IRC server via a JavaScript form. It then connects. It sends this one message. I'm going to DCC chat. That's your client doing this, your browser. And I want them to connect back to me on port 22. Your router sees this and says, I better let that person back in when they connect. It then port forwards port 22 to your system behind your NAT. I just broke into your NAT. And I can connect you on any port that you have. If you have a NAT, you are not safe. This is what happens. When you're running SendMail from 1982 on your computer, and you're like, I'm behind a router, it's fine, behind my firewall. You're not. People will connect, even if they're not on your router. This can happen. It's amazing. It's really cool. So here's an example code that will actually do just this. It will open up any port you want. You just set the port variable. You set 22. You could set 80, 443, whatever you want. And now you can now connect to that person who visited your website through their firewall. Now what about block ports? So as this became more and more, a little bit more prevalent, not NAT pinning specifically, but people abusing IRC, what some browsers started doing was saying, oh, you know what, I'm not going to let you connect to 6667. That's a well-known IRC port. You're obviously up to some trouble. So we're going to block port 6667. Well, the great guys at Goatsy figured out that you can do something pretty cool. You can overflow the integer and just add 65,536 to it, add one extra bit. When it hits the browser code in WebKit, for example, it checks, does the port equal 6667? No, it doesn't, because it's this big number. But by the time it gets to the IP stack, it gets overflown to your 32 bits, and it gets back to 6667, just ignoring that whole block. At this point, I believe it's fixed in all WebKit browsers, but for a time it was an issue. I'm not sure if it's still around. So NAT pinning plus integer overflow gets you to basically, you may not even need the integer overflow. You can now break into people's NATs, break into their firewalls, connect to them on any port that they thought they were securely running behind their firewall, and just start attacking. Have fun. So at this point, poor Anna, she was running a web server. What was she doing that for? So I got to go to her website behind her router. Is that Anna? I think so. And apparently she loves Twilight just like me. And Arshan. Actually, Arshan is also a big Twilight guy. We're kind of fighting right now. He's on Team Edward. I'm on Team Jacob. But so is Anna. So is Anna. So thinking, man, and now I know how to seal the deal, right? Team Jacob. I mean, it's meant to be. I'm sorry, Arsnake. It's meant to be. So, I read her blog. It's great. It's good stuff. I love Twilight. And at this point, we should know, how do you stop NAT pinning? I normally don't like to talk about defense, but okay, for you guys. Let's try to stop it. Have a strict firewall. You can turn off connection tracking. A lot of routers, you can turn it off in NATs, some NATs. So turn it off if you can. Make sure you're running up-to-date browsers so that you have, the patches for example, integer overflows and things like that. Make sure you're just running up-to-date browser. Use NoScript if you can. If you're using Firefox, try to protect yourself as much as possible. You guys understand there's no catch-all to full protection. Just use as many layers as you can, as I will with Anna. So now that I know Anna's interests, I might as well send her another message as Arsnake. Really seal the deal. I'm going to let her know, you know what? My friend Sammy's going to come over. He's a good guy. I'm out of town. I'm at Blackhat. I'm flying back to meet her tonight. And actually go check his Twitter, Nambla/Twitter. And so hopefully she'll be expecting me. And luckily I had her boyfriend saying, oh, he's a good guy, social proof. I'm sure you guys are all social engineers. Asking me my passwords. So, the moment you've all been waiting for, right? XXX, SS. This is going to be amazing. Don't worry, he'll keep it on. My final attack, I think the coolest attack. We're going to do geolocation. All right, that's not that interesting. Whatever.